don't let me down now. Okay, I think it's working. Yes. Okay, so f prime of theta, I have to differentiate arcsine. Arcsine is 1 over the square root of 1 minus whatever I have hidden here squared. But what I have hidden here is already has the square root. So when I square this, I will just write this. Not pi, but 11. 11 theta. Okay, so I differentiated arcsine as 1 over the square root of 1 minus this squared. But now I have to differentiate the square root. That's my second function that I have to differentiate. So this is times 1 over 2 the square root of sine 11 theta times the inner function prime, which is function 3. So times cosine 11 theta times the derivative of function 4, 11. Is this clear? Should I do this again?
I'm good.
So the only thing I would do is I would just rearrange it a little bit, maybe take the 2 in front and put this in the numerator. So I will have 2 cosine 11 theta divided by 2. I'll put the square root of sine 11 theta here and the square root at the end, the other one. So 1 minus sine pi theta. I keep writing pi. I have no reason. It looks like pi to me, but it's 11. Is this better?
Yes.
Thank you. Good. Anything else you would like to go back to?
I'm sorry, where did the 2 come from? I just couldn't see in the...
Oh, right, because it's 11, and in my mind it's 2. It makes no
okay.
It makes no sense.
No, it's fine.
In my head there is yeah. I meant 11, of course. My apologies, no excuse.
Oh, thank you.
I'm confused on the 1 minus sine part, on how you got that.
Oh, yes. So remember when we differentiate arcsine, arc sine of a function prime.
Yes.
That's okay. That's okay. Is 1 over the square root of 1 minus the function squared times the function prime.
Thank you.
It's fine. I'm glad you can see me because I'm just literally sitting on less than a quarter of a chair because I don't have room. My keyboard is here, my document camera is here, my tablet is in my elbow, I'm on 1 square inch. I have to rearrange the whole thing. My earlier classes told me that my setup with the 2 cameras wasn't working on the same computer, so I had to start with the tablet on the side. Good. No excuse though. I'm not trying to. Good. Next question. Anything else you'd like to? Shreya, is this okay?
Yes, thank you.
Thank you. Okay, next question. Anything else you have for me? And we're not finishing, but I'm just saying I want to thank you very much for putting up with me this week so I can see what glitches need to be fixed and what is the best setting that we can hold our class moving forward. And the fact that you are agreeing to take the test, at least the first one, I mean test 2, on a Sunday is just making such a big difference. Good. Next question. Anything else you would like to work on?
This is from the Chapter 3 review test packet.
I'm so
So-
sorry. I left the phone on. I'm teaching right now, Irv. I'll call you back. Thank you. Sorry. You said problem 3. The
Oh,
reason
no.
I left it on is because some of the students can get in and they call me, so that's the only reason. Sorry about that.
I'm sorry, this is from the Chapter 3 math review packet.
Oh yeah. Okay. So
Is,
let me open that. I should have been ready with that. Sorry. It was an insane day. Absolutely insane. My apologies. So, okay, so it's opening. So we want to look at problem 3. Okay, very good. I thought we did that, but let's do it again, even if we did it.
I meant, so this is from the Chapter 3 review packet, question number 6.
Oh, sorry. Question 5, question 6. Oh, yes. Very good. So you want to talk about tangent 3 degrees.
Correct.
Okay. So remember, I don't want you to memorize this, but this is extremely important that delta y is not equal to, but approximately dy. This is the exact change, the exact error in the function, which is f of x plus dx minus f of x. So this is the error in x, and this is the exact error created in the function. But this is approximately the differential of y, not the derivative, but the differential of y, which is f prime of x times dx. Let me see, I can't see what you see. Okay, now I see. So we're moving this to the other side. So this is f of x plus dx, approximately f of x plus f prime of x dx. And I know you know it's all the same thing. So this is my tangent 3 degrees. So this is what I have to approximate. So I have to identify the function. I have to identify x. I have to identify dx. And of course, I need f prime. Once I identify all these and I have all these pieces, I just have to put them in here. So, can anyone give us the function that we have in this problem? What is the function?
Is it f of x plus f prime dx per tangent?
That's what we have, right?
Yes.
Tangent x, and I know f prime is secant squared. Now I have to identify x and dx. And remember, when it comes to trig functions, that's all we know. 0 degrees, pi over 6, or 0 radians, pi over 6, pi over 4, pi over 3. We know pi, we know 3 pi over 2, and we know 2 pi. We do not know anything else. And combinations of these, but nothing else. So I need to identify x based on these angles. If you want in degrees, it's 0, 30, 45, 60, so on and so forth. something close to 3 degrees. So which of these, because these are much larger, so I'm not even thinking of those, but which of these is the closest to 0? To 3.
0.
I'm sorry. Good. So then dx is 3 degrees. But I cannot use 3 degrees here, outside of a trig function. I have to change it into radians. Very easy to remember how to change degrees into radians. This point is pi as well as 180, so they have to be the same, this point. So then pi equals 180 degrees, which means if I want 1 degree, I divide by 180. If I want 1 radian, I divide by pi. So I cannot leave 3 degrees. I have to multiply it by 3 times 1, which means 3 times pi over 180. And I will have to simplify. So this is pi over 60. This piece will be pi over 60. Inside a trig function, it doesn't matter if I have degrees or radians. The answer will be only 1. But if it's outside in this formula, I have to have radians. When we see pi, we don't have to write radians, but I just wanted to emphasize. It's clear that it's in radians. So then, so all I have to do is just write that. So I have the tangent. Let me write it again. I think it's better. Tangent 3 degrees is approximately f of x. X is 0, tangent 0. And then f prime is secant squared of x, which is 0. So that's plus secant squared 0. And then times pi over 60. So I replaced this by tangent 0, this by secant squared 0, and this by pi over 60. So therefore, I know that tangent 0 is, now I can write the equal symbol. Here I cannot, but here I can, from here, here. So tangent 0 is
0.
very good. Plus secant squared 0, I'm interested in cosine 0 first. Once I have cosine, I know that secant 0 is 1 over cosine 0. So how much is cosine 0?
Is 1.
And 1 over 1 will be 1. So obviously secant squared will be 1, and times pi over 60. So the answer is pi over 60. Of course, I want to double check my work. And I go to tangent. I put 3, close the parenthesis, but I have to check. If it's not in degree mode, I should not touch it. It is in degree mode. So, oops, I didn't mean to turn it off. So, so this is the answer. And now I will divide pi by 60, and the answer has to be very close. So 1, 2, 3. So at the thousandth digit from 3 to 4. This is the approximation, and this is the exact. And which is really quite good. You don't have to. This is good enough. So you're saying that tangent 3 degrees is approximately pi over 60. But I have to check, make sure that I didn't make an error somewhere. Very good. Next question. Is there anything else that you would like to go back to? I have the book here if you need to select anything from the book. If you want me to choose anything.
I don't have anything in particular, so if you want to choose something, that's fine.
Very good. Anyone else, or can I get my book?
I'm out of questions to ask.
Okay, very good. So my book just grew legs. No, I got it. It's right here. It's kind of falling apart. What about this? If we did this problem before, let me know. The volume of a cube is increasing at a rate of 10 cubic centimeters per minute. How fast is the surface area increasing when the length of an edge is 30 centimeters? Is it a yes, or we select another?
Looks like a good one to me.
Let's give it a try.
Okay, very good. So I copied the information. So this is problem 97 on 267. And we have 10 cubic centimeters per minute. And we're asked to find how fast is the surface area increasing when the length of an edge, I'm going to call it x, equals 30 centimeters. So I need to identify what this is. I don't have to draw a cube, but I will. With all sides x. One more time, the volume of a cube is increasing at a rate of 10 cubic centimeters per minute. What is this?
dv over dt.
Thank you. And how fast is the surface area increasing when the length of an edge is 30? It's so heavy I have to put it away.
Would that be delta H over T?
But it's d, right? So the surface area, ds over dt. How fast is the surface area increasing when the side is 30? Is that okay?
Yes.
Perfect. Okay, so I have to start with the volume. I have to create the surface area and take it from there. So what is the volume of a cube equal to?
X cubed.
Very good. What about the surface area of the cube? Yes, 6x squared. 6 surfaces of x times x. Great job. Perfect. So obviously, when we increase the volume of a cube, the surface area increases, and also the length of each side increases, right? So since we are asked, obviously, this is a function of time, this is a function of time, and this is a function of time. They're all functions of time. So let's start with what we're asked to determine and see what we need. So how much is ds over dt?
12x. Oh. Times x. Or
One more time. V, S, and x are all functions of time.
Oh, so df dx over dt.
Exactly.
dt.
Because when we increase the volume, we must increase the side, we must increase the surface area. Good. So now when x is 30, I don't have a problem. This is a number, this is 30, but I do have a problem because I don't have this. But let's differentiate the volume, the equation of the volume both sides. What do we get?
So dv over dt equals 3x dx over dt, 3x squared.
Agreed? I have this, it's 10. I have this, it's 30 now. And I don't have the x over dt. I determine it and then plunge it in because I don't have it. So I have this, which is 30, I have 12, and I don't have this, but I can, by differentiating the volume both sides, and I get this, 3x squared dx over dt, then I can determine the x over dt at that particular instant. That's all I care about when x is 30. So this will be dx over dt equals 10 divided by 3 times 900. Have to square first. 900 times 3, 27. I'll simplify. And now I plug it in. So then I have ds over dt equals 12 times 30 times 1 over 270. And I'll simplify, and I get 9 and 12 over 9. I will simplify again by 3. And I get 4 divided by 3. Measurement unit.
Centimeters per minute.
Careful.
Oh, squared.
Yes.
Squared.
Yes. Yes. Very good. That's it. Does it make sense?
Yes.
Can you think of any other type of problems that we should go back to? Anything else?
Is it possible to look at a hyperbolic function?
Oh, yes, of course. You want to look at this one?
I'll let you pick whatever is best because I can't see it too well.
Oh, okay. So my question is, do you just want a differentiation or a word problem?
How about just a differentiation?
Differentiation. Very good.
Yes.
I'm getting another warning of 10 minutes. So sorry. Okay, differentiation. So I don't remember if we did 42. Let's do 42. I have to hold the book with one hand. So 42 on 263. and y equals x, hyperbolic tangent. It's inverse, which I will not ask you. I'm just going to change it. I'm going to change this into a hyperbolic tangent x plus natural log of the square root of 1 minus x squared. Because I did not ask you to memorize, and I will not ask you to memorize the derivatives of, they're not difficult, but they're not, I wouldn't say useful. They are useful, but they're not very common. So I didn't ask you. If I put something like this, I will not. I will give you the formula, but you don't have to memorize it. So that's why I changed the function. It was the inverse of tangent, hyperbolic. Okay, so y prime. Obviously, this is a product. So I have to use the product rule. X prime is 1, so hyperbolic tangent plus x times hyperbolic tangent prime is hyperbolic secant squared. Now plus, and I have to differentiate the natural log. It's 1 over the square root of 1 minus x squared, but times the inner function prime. This is the inner function. So it's 1 over 2 the square root of 1 minus x squared. And don't forget the inner function prime, which is negative 2x. I can simplify a little bit, and I can multiply these two, and I'll get an expression without the square root. So I will copy hyperbolic tangent. I will copy plus x times hyperbolic squared x, secant, hyperbolic secant squared x. And then this is just minus x over 1 minus x squared. Is this something that you had in mind, Sean?
Yes, it is.
Anything else you would like to work on?
I don't have anything else at the moment. Thank you, though.
Sure. Would you like to finish WebAssign between now and Monday? So I will more than happily answer your questions on Monday, but I'd like to start chapter 4. And then we'll take our test 2 the following Sunday.
Sounds good.
Yep, sounds good.
Okay, so I did not email, as I said, today was just an absolute hectic day. I did not get a chance to email you, but I will right now before I turn this off. I will email everyone with the suggestions. I would prefer 2 to 4 or 3 to 5.
For when we do take the test,